Hey there, mathematicians. It's Miss Johnson. Today we're going to be looking at sample spaces and how we can use sample spaces to find simple probability. So a sample space is just basically all the possible events or things that could happen. So let's take, for instance, if we flip a coin. If we flip a coin, two things can happen. We can get heads or we can get tails. And that is literally what the sample space is. We can flip the coin and we can get heads or we can get tails. That's a sample space. That's the two things that can happen. If we roll the dice, what can we get? We can roll a 1, we can roll a 2, 3, 4, 5, or 6. That's the sample space. If we run, we're not going to run the die, we're going to roll the die. If we roll the die, that's a sample space. That's all the things that could happen. What about this bag over here with these marbles that kind of look like Skittles? What would be the sample space for that? Well, we can pull 2 different blues, or we can pull 3 different reds, and that's the sample space. For the spinner, it would literally just be the colors red, yellow, blue, and green. That's all a sample space is. It is literally as simple as that. So how do we use that to help us with simple probability? So simple probability is the chance that an event will happen. It's a fraction of the desired number of outcomes over the total number of outcomes. And it's written right here, so desired number of outcomes over the total. The answer can be expressed as a percentage, but it can also be expressed as a fraction. And it's written this way, with a capital P, and then in parentheses will be the desired event. And it said the probability of whatever the desired event is, and then it'll give the probability. Don't worry, we'll practice. You'll get it. All right, so our first question is, what is the probability of flipping a tail on a penny? So there's our penny, there's our sample space. We can either get a heads or we can get a tails. So it's the probability of flipping the coin and getting a tail equals how many tails can we get out of the total number of outcomes. So we can get 1 tail out of 2 different outcomes because we can get heads or tails, so that's 2 outcomes, and then only one of them is tails, so that's 1 out of 2, which we know 1/2 is 50%. What is the probability? So number 2 is, what is the probability of rolling an even number on a die? An even number. So here's our sample space. That's all the things that can happen. We can get a 1, 2, 3, 4, 5, or 6. And here we have the probability of rolling an even number equals the total number of even numbers over the total number of numbers. So how many even numbers do we have? We have 1, 2, 3. Remember, even numbers, in the ones place, there'll be a 2, 4, 6, 8, or a 0. And then odd numbers have the 1, 3, 5, 7, or 9 in the ones place. Okay, so we have 3 even numbers. So our numerator is going to be 3. I'm going to put it down at the bottom just for room. So 3 even numbers out of how many numbers do we have? We have 6, so 3 out of 6. You should always simplify unless you're specifically told not to. So 3 divided by 3 is 1, and 6 divided by 3 is 2. So we have a 50% chance of rolling the die and getting an even number. All right, our third question is, what is the probability of rolling a number greater than 4 on a die? rolling a number greater than 4 on a die. So same sample space, 1, 2, 3, 4, 5, 6. That's the only things that can happen when we roll the die. So we have the probability greater than 4. So we need the numbers that are greater than 4 over the total number of numbers. So how many numbers are greater than 4? We have 1, 2. Only 5 and 6 are greater. 4 is equal to 4, so that's not greater than. So we have 2 numbers out of 6. Of course, we are going to simplify that. So 2 divided by 2 is 1, and 6 divided by 2 is 3. If you haven't yet memorized that 1/3 is 33.3 repeating percent, or 33 and 1/3 is another way to write that. If you haven't memorized that, you need to memorize that because that is used a lot in math. So that's one that you should memorize. So the probability of rolling a number that's greater than 4 is 1/3, or 1 out of 3, or 33 and 1/3%. All right, number 4, going back to that bag, it says, what is the probability of pulling a blue marble? So we have the probability of blue. So we have 2 blues, 3 reds. So the number of blues is, let's use a blue, is 2 out of 5. I almost put 6 because of the dice. So 1, 2, 3, 4, 5. Can't be simplified. It's already simplified. And then 2/5, I believe, is 40%. If I wanted to check to make sure, we would divide it. That's 0.4. And then move it. So 40% is correct. So there's a 40% chance of pulling a blue marble, or 2 out of 5 chance. All right, let's look at the spinner. So the spinner has a red, yellow, blue, green, and they're all equal sizes. So it says, what is the probability that the spinner will land on yellow? So probability of yellow, so the total number of yellow pieces, we have 1 yellow piece out of 1, 2, 3, 4. So our probability is going to be 1 out of 4. That can't be simplified. Hopefully 1/4 is another one that you have memorized, which is 25%. So notice in all of these that we've done so far, only one thing has happened, right? We flipped one coin, we rolled one die, rolled another die, pulled one time, spun one time. Well, in this one, it's going to seem like we're doing 2 things, but we're really only doing 1. It says Jackson rolled 2 dice. So he rolled them at the same time. He added the 2 dice together to find the sum of the roll. The chart shows all of the different outcomes. So this chart shows us all the different things that could happen. So this is the sample space. This is all the different sums that could come up with. So here we have one dice, he could have got 1, 2, 3, 4, 5, 6. The other dice, he could have got 1, 2, 3, 4, 5, 6. And then it says sum, so 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4, right? 2 plus 2 is 4. 2 plus 3 is 5. So you see how it goes. It kind of works like a multiplication chart, except it did the sums, right? All right, let's look at the question. It says, what is the probability when 2 dice are rolled that the sum of the dice will be less than 5? So the probability is the sum is less than 5. So let's look at all the numbers, all the sums, I should say, that are less than 5. Because we're not going to include the numbers in gray, because those aren't the sums. Those represent what's on the die. So 2, that's less than 5. 3 is less than 5. 4 is less than 5. Should we do the 5s? Are 5s less than 5? No, they're equal, so we're not going to do those. So we just count, and we see how many there are. 1, 2, 3, 4, 5. So there's 6 numbers that are less than 5. What's the total number of sums? So we could count them, but I'm going to use a multiplication. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 6 times 6 is 36, right? That makes an array, right? So we can just multiply. So 6 times 6 is 36. We definitely should simplify. We can simplify by 6. So 1/6, which I do believe is 16.6 repeating percent. And if you have that memorized, 0.6 repeating equals 2/3. So 16 and 2/3%. So the probability of rolling a sum less than 5 is 1 out of 6. You have a 1 out of 6 chance, so it's okay. It's the same as rolling like a 3 on the die or whatever. So 16.6 repeating percent or 16 and 2/3%. All right, we're going to use one more. We're going to use a sample space one more time. So it says using a sample space from number 6, it says what is the probability when 2 dice are rolled that the sum of the dice will be an odd number? Okay, so I'm going to use a different highlighter, and we're going to look at all the sums that are odd. So remember 3s, 5s, 7s, 9s. 1, 3, 5, 7, 9s in the ones place will give or are the odd numbers. So we're going to highlight all the odd numbers in purple. Makes me wonder if it's going to be like a 50-50 because it's like even and odds, right? I don't know. I wonder. Let's find out. Okay, so let's count. I might actually put the numbers too. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there's 18 odds. And then 6 times 6 is 36. So what number can go into 18 and 36? Well, 9 for sure. So 18 divided by 9 is 2. And 36 divided by 9 is 4. Can we simplify again? Yes, we can. They're both even, right? So that means we can multiply by 2. So, hey, look, it does end up being even. So half of the sums are even and half of the sums were odd. Yeah, that's cool. I didn't know that was going to happen. All right, so we just use sample spaces to find simple probabilities. So simple probabilities are just when one thing happens. We probably didn't need to actually write this out and put the 2 blues and the 3 reds, right? We could have just looked at it here and figured out the number of blues over the total number of marbles. Same thing with this, right? I mean, we can see them. Do we really need to separate them out, right? So when you're finding simple probability, you just use the, or whatever's happening, you just use it to figure out the probability. Now, we will use sample spaces later for compound probability, and we will need it, we can't just look at it we actually have to do something. Okay? All right, so that was sample spaces and simple probability. That's our introduction. You're going to love probability. It's a fun one, I think.